Hello friends, today I'm going to show you how to find the derivative of trigonometric function. To find the derivative of trigonometric function, simply we follow the derivative rule of product and quotient rule. First, let me see some examples from trigonometric function, and it is inverse, it's reciprocal, tanx, cos secx, another one from trigonometric function, f of x equals to 1 over ln x, 1 over ln x. The other one, f of x is secx. To find the derivative of the function, simply we say that this one to follow its form. Solution, f derivative at x. First, the function f of x is equal tan x. Tan x means that sin x over x, cos x means that. Therefore, f derivative at x means that the derivative of sin x over cos x, that means quotient rule, d by dx of the numerator sin x times denominator cos x minus sin x numerator times d by dx of the denominator cos x, the whole over denominator square, cos x the whole square. This equals d by dx of sin x is cos x. The derivative of sin x is equals cos x. Cos x times cos x minus the sin x times the derivative of cos x sin x into minus sin x, because the derivative of cos x is equal to minus sin x, the whole over x, that means cos x the whole square, cos square x. Therefore, cos square x minus sin x times this one is plus, therefore sin square x over cos square x, cos square x. This equals, you can rewrite in such form, sin square x plus cos square x the whole over cos square x. Sin square x plus sin cos square x is 1 over cos square x, because it is trigonometric identity. Since sec x is equals 1 over cos x, therefore this means 1 over cos x the whole square, which equals sec x the whole square, because the second example is that f of x equals cos sec x. The second trigonometric identity, that means the reciprocal of sin x. F of x means that 1 over sin x, since cos sec x is 1 over sin x. There, since we follow quotient rule, f derivative at x is equals d by dx of the denominator 1 times sin x, the denominator, minus 1 times denominator of its derivative, d by dx of sin x, the whole over denominator the whole square, sin x the whole square. Since the derivative of constant function is 0, therefore 0 times sin x becomes 0. The derivative of any function, d by dx of c, where c is any number, 0 minus 1 times d by dx of sin x derivative cos x, therefore minus cos x the whole over sin x the whole square, sin square x. This is equals minus cos x over sin x square, sin x the whole square. We can rewrite in this form, minus, since sin square x is two terms, sin x and sin x, we can separate it into 2, since the operation is quotient. We have 1 minus 1 over sin x times cos x over sin x. since cot x means that cos x the whole 1 over tan x means over cos x over sin x, and cosec x means that cosec x is equals 1 over sin x. We can substitute this cot x and cosec x instead of 1 over sin x and 1 cos x over sin x. Therefore, we can rewrite the function f derivative at x is equals minus 1 over sin x is cosec x minus cosec x times cos x over sin x means that cot x. Therefore, we can rewrite this form cot x times cosec x. This one is a derivative function cosec x with respect to x. This one is a solution set. The third example is that it is actually it is not a trigonometric identity. It is a logarithm function with respect to base e, natural logarithm. Therefore, since it is also quotient rule, we can follow the quotient rule of derivative function. Therefore, f derivative at x is equals d by dx with the denominator times denominator minus numerator times d by dx of denominator. Therefore, d by dx of 1 times ln x minus 1 times d by dx of ln x the whole over ln x the whole square. Ln x, since the denominator is ln x the whole square. This is equals d by dx of 1 ln x means that since the derivative of constant number is 0, therefore this one becomes 0. 0 minus 1 times d by dx of ln x means that 1 over x the whole over ln x the whole square. Ln x the whole square. As you remember, in division rule or quotient rule, a over b the whole over c means that a over b bc times 1 over c with a over bc. This we can rewrite this in such form: minus 1 over x minus 1 x ln x the whole square. This is the derivative function. The function f of x equals 1 over ln x. Its derivative seems like this one. Since derivative of, we can separate it by using quotient rule. Ln x the whole square minus 1 this becomes 0. Therefore, 0 minus 1 over x the whole over d by dx of ln x means that 1 over x and the denominator square ln x the whole square. Therefore, a over b over c means that a over bc. Therefore, the function derivative becomes this one. The third example, actually, fourth example, f of x equals 1 over x square minus 4x plus 6. The denominator is a polynomial function with degree 2. As usual, we can use it d by dx of 1 times the denominator x square minus 4x plus 6 times 1 times the d by dx of x square minus 4x plus 6 the whole over x square minus 4x plus 6 the whole square, denominator square. This becomes d by dx of 1, this one 0, therefore minus x square minus 4x plus 4, the degree is 2, therefore the derivative is 2x minus 4, plus, the derivative of 6 is 0, therefore we can erase it. The whole over x square minus 4x plus 6 is the whole square. This becomes minus 2x plus 4 the whole over x square minus 4x plus 6 the whole square. This is a derivative function 1 over x squared minus 4x plus 6 with respect to y, with respect to x. And the last example for today's discussion is that f of x is cos sec x, sec x, if or since f of x is sec x equals 1 over cos x, therefore we can rewrite f derivative at x as divide x of 1 times cos x, 1 times cos x minus 1 times divide x of cos x, divide x of cos x, cos x, the whole over the numerator square, the whole over numerator cos x, the whole square. Since the derivative of constant number is 0, we can say that this one is 0, therefore 0 minus 1 times the minus sin x over cos x, the whole square. This is equal sin x. This is minus of minus sin x is equals sin x over cos x the whole square. We can separate the numerator into two terms or two proportions. Therefore, we can rewrite this function as this one, because this one is 0 and this one become minus sin x. Therefore, you can rewrite sin x over cos x times 1 over cos x, 1 over cos x. As we know, sin x over cos x is tan x. Therefore, since 1 over cos x is sec x, we can rewrite this one sin x over cos x tan x times 1 over cos x is sec x. Therefore, the function f of x is f derivative of x equals tan x sec x. Tan x sec x is the derivative function sec x.